Tonight, we're going to take a slow, unhurried walk into the distant past. Not to solve a mystery, not to prove a theory, just to sit with one of the oldest civilizations we know and let its story unfold at its own pace. This is a quiet journey into ancient Sumer. There's nothing you need to remember, nothing you need to figure out. You can simply listen, breathe, and let the details drift by. If your thoughts wander, that's perfectly fine. If sleep arrives before the story does, that's even better. This is a space for rest, for slowing down, for letting history speak softly instead of loudly. We'll look at how the Sumerians seem to appear suddenly in the historical record, already skilled, already organized. We'll explore their cities, their writing, and the systems they used to measure time and the sky. And we'll touch on their own belief that they were not inventing civilization, but restoring something much older. So settle in, adjust your pillow, and when you're ready, we'll begin. The Sumerians remain one of history's quiet puzzles because they do not seem to grow into civilization the way most cultures do. Around 3500 BCE, in the land between the Tigris and Euphrates rivers, they appear already settled in cities. These were not temporary camps or scattered farming villages. They were planned communities with defined streets, large temples, organized labor, and systems for managing water in a difficult environment. History usually moves in small steps. Tools improve slowly. Shelters become homes over generations. Writing develops from simple marks into complex symbols. But in Sumer, many of these steps are missing. Writing arrives already structured. Mathematics is already in use. Architecture already shows careful planning and symbolic design. It feels less like the first chapter of a story and more like opening a book halfway through. The Sumerians counted using a system based on 60, a method so practical that parts of it still shape our lives today in the way we measure time and angles. Their writing system, cuneiform, began with hundreds of symbols, complex enough to require long training. There is no clear trail showing how it evolved into existence. It simply appears, pressed into clay, as if it had already been practiced elsewhere. Their cities were anchored by massive temple structures called ziggurats, rising in steps toward the sky. These buildings were not placed at random. They were aligned with celestial movements connecting earth, sky, and ritual. Their irrigation canals controlled unpredictable rivers. Their trade networks stretched far beyond their homeland. None of this suggests experimentation. It suggests confidence. For generations, scholars have tried to explain this sudden sophistication. Some believe earlier stages of development were erased by floods and time. Others suggest knowledge was inherited from cultures that vanished without leaving records. But the most intriguing explanation comes from the Sumerians themselves. In their own texts, they do not describe themselves as the originators of civilization. They speak instead of receiving order, law, and knowledge from a time before. They describe kingship as something that descended, not something that was invented. Again and again, they frame their work as preservation rather than creation, as if they were caretakers of memory rather than pioneers of progress. When archaeologists handle Sumerian tablets today, the past feels unusually close. These records were made by hand, using reeds pressed into soft clay. Some still carry the fingerprints of the scribes who shaped them, left behind before the clay hardened. These small impressions belong to people who lived more than 5,000 years ago, quietly recording what they believed was important to save. What they chose to record is striking, detailed observations of planets, mathematical exercises, medical instructions, legal agreements, myths that speak of earlier ages, long rains, and a great flood that divided history into before and after. Flood stories appear in many cultures, separated by oceans and centuries. When similar memories echo across distant civilizations, it invites a question worth sitting with, even in silence. Are these only stories, or are they fragments of something once experienced? Archaeology offers a quiet response. In several ancient Sumerian cities, thick layers of flood sediment separate older ruins from newer ones. These layers suggest a powerful regional disaster, strong enough to erase entire settlements and force survivors to rebuild. Not the end of the world, but the end of a world. What makes this discovery unsettling is not just what the Sumerians built, but what they believed they were doing. Their records suggest they were not inventing a new civilization. They believed they were repairing a broken one. Again and again, their writings describe history as divided into two eras, a time that existed before destruction and a time that came after it. Between those two periods was a disaster so severe that it erased cities, knowledge, and memory. Water, collapse, silence. In the world that followed, the Sumerians did not see themselves as founders. They saw themselves as restorers. This belief changes how we should understand their achievements. When archaeologists first began digging at Uruk, one of the earliest Sumerian cities, expectations were modest. Most scholars assumed they would find rough beginnings, trial and error, simple layouts, signs of a society learning how to function. Instead, Uruk revealed something very different. The city was surrounded by more than 6 miles of defensive walls, carefully measured and deliberately placed. Inside those walls were canals and water systems designed with precise calculations. These were not guesses. They were solutions refined by experience. At the heart of the city stood a massive temple complex. Its alignment was not random. It tracked the movement of the sun, including the winter solstice. This required long-term observation of the sky and a deep understanding of seasonal cycles. Nothing about this city suggested an early experiment. Everything suggested knowledge already in use. Then came the tablets. Buried beneath collapsed structures, archaeologists uncovered tens of thousands of clay tablets, over 40,000 in Uruk alone. This was not a symbolic archive or a royal collection. It was a working memory system. These tablets recorded trade transactions, crop yields, religious ceremonies, medical practices, school exercises, star movements, and legal decisions. They documented how people lived, worked, worshipped, and understood the universe around them. But what stands out is not just what the tablets contain, it is what they do not say. Nowhere do the Sumerians describe a moment of invention. They do not say, "This is where writing began," or "This is how we discovered mathematics." Instead, they speak of preservation, of continuity, of restoring order after chaos. In temple inscriptions and royal dedications, One phrase appears again and again, carved into stone and clay meant to last beyond lifetimes. This is the restoration of what was before. Not creation, restoration. This language suggests a society deeply aware of loss, a people who believed much of human knowledge had already existed, had already been mastered, and had already been destroyed. Their task, as they saw it, was not to move history forward, but to rescue it from forgetting. In a museum in Berlin, a small clay cylinder sits behind glass. It describes the building of a temple dedicated to Inanna, the goddess associated with the evening star. The text follows formal tradition: praise, devotion, authority. Yet hidden within the official language is that familiar idea once more. This work is not new. It is a return, a rebuilding. Pressed into the surface of the cylinder are faint fingerprints. They belong to the scribe who shaped it more than 4,000 years ago. The clay was soft when those hands touched it. The marks were never meant to be seen. And yet they remain. Proof of someone who believed this object mattered enough to survive fire, flood, and time. Someone who thought memory itself needed protection. This concern with memory runs through nearly all Sumerian writing. Their myths speak of a time before devastation, when humans lived closer to the gods and knowledge moved freely. They describe rulers who reigned for lifetimes far longer than any human lifespan. They tell of teachers who came from the heavens and showed humanity how to measure land, chart stars, and build cities. These stories are often dismissed as fantasy. But similar themes appear in cultures far removed from Sumer, separated by oceans and centuries. Flood stories appear across the ancient world. So do stories of destruction followed by survival. While the details differ, the pattern remains: loss, preservation, rebuilding. Archaeology offers clues that something real may sit beneath these traditions. In the early 20th century, excavations in several Sumerian cities revealed thick layers of flood sediment. At Ur, a deep layer of clean silt separated older ruins from newer ones. The same type of layer appeared at Kish, Shuruppak, and Eridu. These were not minor floods. The clay was sterile, showing no signs of normal life. Entire cities had been buried at once. The flood was not worldwide, but for southern Mesopotamia, it was devastating enough to wipe the slate clean. Civilization in the region did not slowly evolve after this event. It restarted. Clay tablets became the unexpected survivors of that restart. Unlike wood or parchment, clay reacts strangely to disaster. Fire does not destroy it, it strengthens it. When ancient buildings burned, the tablets inside were baked hard, like pottery in a kiln. Floods collapsed walls, but the tablets buried beneath them endured. Over thousands of years, wind eroded cities away, yet the writing remained. Memory survived because catastrophe failed to erase it. Today, the ruins of Uruk still rise from the desert of southern Iraq. The heat is intense, the air is dry, broken walls form patterns that once held tens of thousands of people. These stones supported ceremonies, trade, prayer, and observation under open skies filled with stars. What remains is quiet, but beneath the surface lie layers of rebuilding, each one resting on the ruins of what came before. And beneath all of it are the tablets, still holding the voice of a people who believed they were not at the beginning of history, but standing among its fragments, trying to save what they could. The land here is never still. Wind moves the sand like water, lifting it from one place and laying it down in another. What is buried one season may be exposed the next. Walls appear, then vanish again. Doorways emerge only to be swallowed once more. And beneath all of it, beneath the dust, the broken bricks, the empty foundations, are the clay tablets. Thousands of them, sometimes millions, silent, heavy, waiting. When the first large excavations began in Mesopotamia in the late 19th century, the people leading them were not searching for writing. Men like Hormuzd Rassam, Ernest de Sarzec, and Robert Calderway were treasure hunters by the standards of their time. They were looking for statues, reliefs, precious metals, objects that could be displayed, sold, or admired. Clay tablets were not valuable. They were fragile, dull, and often broken. Many were discarded or ignored in the early years. What those archaeologists uncovered instead of gold were storage rooms filled with records. Shelves collapsed under the weight of clay, boxes packed tight with tablets no larger than a hand, receipts, inventories, loan agreements, lists of workers and wages. At first glance, it all seemed painfully ordinary. Bureaucracy, accounting, paperwork, except written in mud. But when the tablets were cleaned, sorted, and slowly deciphered, something unexpected happened. The ordinary disappeared. What remained was astonishing. One tablet from the city of Nippur lists daily rations given to temple workers, measured amounts of barley, oil, and wool. It looks simple, almost boring. But nearby, another tablet contains a student's math exercises, rows of multiplication tables, calculations involving squares and cube roots. These were not advanced scholars. These were trainees, learning skills that required abstract thinking and numerical systems already in place. A few shelves away, a medical text describes treatments for infections. It lists plant-based ingredients, thyme, cedar resin, fermented barley, combined in specific ways. There is no magic here, no prayers or charms. Just observation, diagnosis, and treatment. In the same archive are hymns written in poetic language praising the goddess Inanna, alongside detailed instructions for predicting lunar eclipses. There are legal cases arguing over property boundaries. There are farming guides explaining when to irrigate fields based on the behavior of seasonal floods. All of this existed side by side. This was not a society slowly discovering how to express itself. This was a society already fluent in administration, science, religion, law, mathematics, and astronomy, all at once. The earliest Sumerian tablets we possess date to roughly 3,500 to 3,200 BCE. From their very first appearance, the writing system they use, cuneiform, is fully functional. It is capable of recording complex legal ideas, poetic imagery, technical measurements, and layered meaning. There are no crude early forms, no half-formed symbols struggling toward clarity. Linguists describe this as highly unusual. Writing systems do not normally appear this way. Egyptian hieroglyphs developed gradually, beginning as simple images and slowly becoming abstract over centuries. Chinese writing evolved over long periods from scratches on oracle bones into standardized characters. The alphabet used today traces its roots through thousands of years of adaptation and simplification. In every known case, writing shows its growing pains. Except here, Cuneiform appears complete, as if it skipped its childhood, and the content of the writing raises even more questions. Among the tablets found at Uruk is a detailed land survey. It maps field boundaries, irrigation channels, and ownership across the city-state. To create this, the scribes needed geometry, surveying tools, standardized units of measurement, and a bureaucracy capable of preserving records across generations. None of this is experimental. It is organized, consistent, and systematized from the start. At Eridu, traditionally considered the oldest Sumerian city, temple hymns refer not to new foundations, but to earlier ones, older temples, older rituals, older designs. The priests there do not describe themselves as founders, they describe themselves as caretakers. One inscription from the Temple of Enki reads, in essence, that the structure was not built for the first time, not established anew, but carried forward from distant days. Scholars once dismissed language like this as exaggeration. Religious tradition meant to make institutions seem ancient and authoritative. But the same phrasing appears again and again across cities and centuries. At Lagash, a boundary stone from around 2450 BCE records a treaty between rival city-states. Before explaining the agreement, the inscription states that the border itself was not newly created. It was restored. The stone emphasizes this point: restored, not invented. At Nippur, the spiritual center of Sumer, temple inventories list sacred objects said to come from before memory. Clay cones buried in temple foundations describe renovations of buildings whose original builders are unknown, even to the scribes recording the work. The pattern is consistent. The Sumerians present themselves not as originators, but as stewards. This would not be remarkable if Sumer had clearly grown out of a sophisticated ancestral culture. But it did not. The Ubaid culture that preceded Sumer in the same region was relatively simple. Small farming settlements, modest tools, basic pottery. There is no evidence of advanced writing, large-scale urban planning, or complex mathematics. Then, in what amounts to a geological instant, cities appear. Large ones, planned ones. Fully formed, there is no long trail of increasingly complex villages, no gradual ramp-up that fits standard models of civilization. There is a break, a gap, and on the other side of that gap stands Sumer. The Sumerians themselves seem aware of this discontinuity. Not once do they tell a story about inventing writing or discovering mathematics. Their myths do not celebrate first steps. Instead, they describe knowledge being received, given, taught. In many stories, divine figures descend from the heavens bringing tools of civilization already perfected. Laws, measurement, writing, agriculture. The myth of Enmerkar and the Lord of Arata contains a particularly strange passage. It describes a distant age when humanity lived without fear. No predators, no conflict. Everyone spoke one language. The land was unified. Then Enki, the god of wisdom and fresh water, changes human speech. He introduces division where there was once unity. This passage has puzzled scholars for generations. It does not read like a creation myth. It reads like a memory of fragmentation, of something whole being broken apart. The idea appears elsewhere. In king lists, that stretch impossibly far into the past, in flood stories that divide history into before and after, in repeated references to ancient designs and distant days. Over time, a picture forms, not of a civilization inventing itself, but of one assembling pieces left behind. In scribal schools, where writing was taught and preserved, students copied older texts again and again. One instructional tablet tells students that the scribal art comes from distant days and must be preserved, not created, preserved. Clay, unlike paper, does not forget easily. Fire hardens it, flood buries it safely. Time wears away cities, but tablets endure. What survives does so by accident, by disaster, by collapse. The Sumerians understood this. They wrote as if they feared forgetting more than death, as if memory itself were fragile. When you sit with these tablets long enough, when you read contracts, hymns, calculations, and star charts side by side, a quiet idea begins to take shape. The Sumerians never claimed to be the first. They claimed to be the ones who remembered, the ones who rebuilt, the ones who carried knowledge forward after something had gone terribly wrong. If they were right, if these tablets are not myth-making but record-keeping, then the sudden rise of Sumer stops looking like a beginning. It starts to look like survival. In Egypt, history unfolds in layers so orderly that archaeologists often describe it as reading a book backward. You can peel civilization away, one chapter at a time. In the Nile Delta, the story begins with the late pre-dynastic period, around 3200 BCE, when burial practices become more elaborate and the earliest forms of hieroglyphic symbols appear. These symbols are rough and experimental, clearly in transition from images to writing. Before this stage lies an earlier phase marked by improved pottery and growing trade networks. Go further back, and settlements become smaller, simpler, more rural. At the bottom of the sequence is the Badarian culture. Early farmers using basic tools, living in seasonal camps, learning how to shape land and food into something stable. Nothing appears suddenly. Each step builds on the last. You can trace progress downward, like descending a ladder. Farming comes before villages. Villages come before towns. Writing grows out of record keeping. Administration follows population growth. The entire process feels slow, logical, almost inevitable. This pattern holds not only in Egypt, but across most of the ancient world. In the Indus Valley, the great cities of Harappa and Mohenjo-daro reached their height around 2500 BCE, displaying remarkable urban planning. Streets follow grids, bricks are standardized. Drainage systems rival those of much later civilizations. Yet archaeologists can follow their roots back through earlier Harappan phases to small farming communities that existed for thousands of years. At sites like Mehrgarh, people experimented slowly with agriculture, metalworking, and trade long before cities emerged. Complexity arrived gradually, earned through trial, failure, and refinement. China tells the same story. The Shang dynasty, known for its bronze casting and oracle bone inscriptions around 1600 BCE, did not appear in isolation. It rests on earlier cultures, early Tu, Longshan, Yangshao, each one extending further back into the Neolithic past. Pottery styles evolve, settlement patterns shift, ritual practices grow more complex. Each generation inherits tools and ideas modifies them, and passes them on. This is how civilizations are expected to form. Knowledge accumulates, skills sharpen, institutions grow slowly enough that their origins remain visible in the archaeological record. Nothing arrives fully formed, except in Sumer. When archaeologists excavate Sumerian sites, they encounter something profoundly different. Instead of gradual buildup, they find sudden complexity. Instead of rough drafts, they uncover finished systems. It is as if the rehearsal phase is missing entirely. The city of Uruk is the clearest example. Around 3500 BCE, in its earliest substantial phase, Uruk already spans more than 250 hectares, roughly 600 acres. This is not a village experimenting with growth, it is a true metropolis. Its defensive walls stretch nearly 10 kilometers, built from millions of standardized mud bricks. Producing bricks on that scale requires centralized planning, organized labor, raw material sourcing, and logistical coordination across years. The mathematics alone is staggering. Builders had to calculate volumes, track resources, plan work schedules, and feed thousands of laborers consistently. Projects of this scale usually come after centuries of smaller civic experiments, granaries, modest walls, early temples. But in Uruk, monumental construction appears immediately. Inside the walls, the city is carefully organized. Residential areas are distinct from industrial zones. Streets are aligned to allow water runoff. Temple complexes occupy deliberate positions, often aligned with cardinal directions. The Temple of Anu, built atop a massive raised platform, demonstrates advanced understanding of structural engineering. Its builders knew how to distribute weight, manage pressure, and prevent collapse. There are no failed prototypes beneath it, no collapsed foundations marking earlier mistakes. The structure works from the start. At Eridu, traditionally considered the oldest Sumerian settlement, expectations were similar. Archaeologists assumed they would find primitive shrines gradually evolving into formal temples. Instead, even the earliest religious structure, dating to around 5000 BCE during the Ubaid period, shows careful design. A central sanctuary, side niches for offerings, intentional orientation. By the time Eridu enters the Sumerian period proper, its temples are so refined that later ziggurats follow their basic layout centuries afterward. The surrounding Ubaid villages show none of this sophistication. They are modest farming communities without monumental architecture or evidence of large-scale coordination. Then suddenly, Eridu emerges with institutional buildings that reflect advanced architectural knowledge. Lagash tells the same story. From its earliest excavated layers, the city is already managing complex irrigation systems. Designing canals is not simple work. Water must flow at the right gradient. Channels must avoid salt-rich soil. Timing must align with seasonal flooding. Cooperation between settlements is essential to prevent conflict over water rights. The canal systems around Lagash functioned effectively from the beginning. Archaeologists do not find abandoned channels or evidence of widespread failure. The system works. Tens of thousands of people depend on it. This stands in sharp contrast to early Egypt, where irrigation took centuries to perfect. Early canals often clogged with silt, flood basins filled unevenly. Crop failures were common. Egyptian agriculture improved slowly through hard-earned experience. Sumerian agriculture appears reliable from its first appearance. The same pattern applies to writing. When cuneiform enters the archaeological record around 3400 to 3200 BCE, it does not look experimental. It already includes around 700 distinct signs. These symbols appear simultaneously in tablets from multiple cities, suggesting wide distribution of a standardized system. For comparison, early Egyptian hieroglyphs begin with fewer than 200 signs and expand gradually over centuries. Chinese writing develops thousands of characters, but over more than a millennium. In both cases, scholars can trace evolution step by step. Cuneiform offers no such trail. From the earliest examples, it combines word signs with phonetic elements, symbols that represent sounds. This hybrid system usually takes a long time to develop, as scribes experiment with different ways to express abstract ideas. Yet in Sumer, this complexity is present immediately. There are no awkward transitional forms, no competing symbol systems, no evidence of trial and error. The script looks taught rather than invented. Law follows the same pattern. The earlier Sumerian legal texts already contain sophisticated concepts: property rights, contracts, inheritance rules, compensation for injury, and distinctions between accidental and intentional harm. These laws recognize social roles and include mechanisms for dispute resolution. Legal systems this detailed normally emerge after generations of legal conflict expose weaknesses in simpler rules. But Sumerian law appears comprehensive from its earliest attestations. Across architecture, agriculture, writing and law, the pattern repeats. Maturity arrives early. Refinement precedes experimentation. Archaeologists refer to this as the Sumerian problem. It is not simply that Sumer developed quickly. It is that development itself seems absent. Between 3500 and 3000 BCE, other regions show villages becoming towns. Sumer shows cities appearing with libraries already stocked. Some scholars argue the missing stages simply have not been found. Perhaps floods or shifting rivers buried earlier settlements beyond reach. Others suggest Sumerian culture developed elsewhere, in regions now submerged, and what we see are already mature offshoots. But there is another possibility, one the Sumerians themselves repeatedly suggest: that they inherited knowledge rather than created it, that Sumer is not the origin but the remnant. If that is true, then the absence of developmental stages is not a mystery. It is evidence. So how did the Sumerians explain their own beginnings? The answer lies in one of the most controversial artifacts ever discovered. In 1906, while cataloguing fragments at the University of Pennsylvania Museum, Hermann Hilprecht noticed a small clay prism from Nippur. It was unlike the usual tablets. Not an inventory, not a hymn. It was a list of kings, but not just recent rulers. This list stretched back far beyond historical time, naming kings who ruled for impossibly long spans, thousands, even tens of thousands of years. According to the text, kingship itself descended from the heavens before the flood. Only afterward did it pass to human rulers. This document became known as the Sumerian King List. Within a few years, it would ignite debates that continue to this day because it forces a question archaeology is not comfortable answering. What if Sumer was not the beginning of civilization, but the memory of something older? What follows is a list of rulers. each attached to a city and a length of reign. The first kings rule in Eridu, then in Bad Tibira, then Larak, Sipar, Shuruppak. 8 kings in total before the text abruptly changes direction. Their reigns are astonishing. One rules for nearly 30,000 years, another for 36,000, another for more than 40,000. These are not rounded figures, they are precise, repeatedly precise. Then, without warning, the list breaks its rhythm. The flood swept over. The sentence is brief, almost casual, and after it, the structure resumes, but everything has changed. Kingship descends again, this time to Kish. The reigns that follow shrink dramatically. Now rulers govern for decades, sometimes centuries, occasionally a millennium at most. Still exaggerated, but recognizably human. This division, the flood as a line separating two kinds of time, is the spine of the document. For much of the 20th century, scholars treated the early section as pure myth. These were assumed to be symbolic figures, representing divine ages rather than real rulers. The later section, by contrast, seemed to overlap with archaeology. Some names matched inscriptions found elsewhere. Some cities corresponded to known political centers. The prevailing interpretation became a gradual transition. Mythology gives way to legend. Legend gives way to history. It was a comfortable explanation. But it left important questions unanswered. Why would the Sumerians record obvious fantasy in the same rigid format they used for historical administration? Their myths exist elsewhere, stories of gods, heroes, journeys to the underworld. Those texts are poetic, emotional, symbolic. The king list is nothing like them. It reads like a ledger: name, city, length of reign, no drama, no explanation, just sequence. Even more puzzling were the numbers themselves. By the mid-20th century, scholars noticed that the pre-flood reign lengths followed strict mathematical patterns. They were not random exaggerations. Almost all were multiples of 3,600, a number of deep importance in Sumerian mathematics. In their base 60 numerical system, 3,600 represented a major unit of time, known as a sar. Smaller units, 60 and 600, nested neatly beneath it. Alulim's reign of 28,800 years equals exactly 8 sar. Alolg's 36,000 years equals 10. Enmenluana's 43,200 equals 12. These figures repeat too consistently to be coincidence. When numbers align this cleanly, they signal calculation, not storytelling. This observation changed how the text could be read. If these numbers are not lifespans, then what are they measuring? The Sumerians were careful observers of the sky. Their tablets show long-term tracking of planets, especially Venus, whose cycles repeat in complex but predictable patterns. They recorded eclipses. They charted conjunctions. They understood that celestial movements operate on timescales far longer than human lives. In a sexagesimal system, long astronomical cycles can be expressed with elegant precision. A sar is not just a large number. It is a unit designed to measure extended time. When reigns are listed in sar, they begin to resemble eras rather than biographies. Viewed this way, the king list stops claiming that individuals lived for tens of thousands of years. Instead, it assigns symbolic rulers to vast spans of time. kings become markers, placeholders for epochs, names attached to cosmic intervals. Consider the largest reigns. 12 Sar equals 43,200 years. That is far longer than any civilization, but it approaches meaningful astronomical periods when expressed as multiples or fractions of known cycles. The precession of the equinoxes, for example, takes roughly 26,000 years. Other long-term planetary relationships unfold across similar scales. If ancient observers tracked these movements for long enough, or inherited records of those who did, such numbers would make sense as timekeeping, not storytelling. Under this interpretation, the king list becomes a chronological framework rather than a myth, a way of organizing deep time, a system for remembering something far older than Sumer itself. Then comes the flood. The text treats it not as allegory, but as an interruption. Everything before it follows one numerical language, large, cyclical, cosmic. Everything after it shifts to another, shorter, irregular, human. The wording emphasizes this break. Kingship descends from heaven before the flood. After the flood, it descends again. The repetition matters. It suggests restoration rather than origin. Order existed. It was disrupted. Order was re-established. This structure mirrors what archaeology has uncovered. Excavations at cities like Shuruppak, Kish, and Ur reveal thick flood layers separating earlier and later occupations. These were not seasonal overflows. They were catastrophic events that buried entire settlements. While the flood was not global, within the Sumerian world it erased everything familiar. If a culture had been tracking long astronomical cycles, cycles longer than any single community's memory, such a flood would have shattered continuity. Records would be lost. Institutions would collapse. Only fragments might survive. The king list may be one of those fragments. What is striking is how later scribes treated the document. Copies were made carefully, errors corrected, damaged signs restored where possible. But there is no sign that later generations fully understood the meaning of the numbers they were preserving. They copied them because the text itself was sacred, authoritative, inherited. This suggests reverence without comprehension. In museum galleries today, you can see this devotion etched into clay. Scribal corrections, careful alignment, marginal adjustments. These were not casual copies. They were acts of preservation. Accuracy mattered, even if interpretation did not. If the pre-flood section encodes epochs rather than lifespans, then the king list is not fantasy layered onto history. It is history, written in a language that later readers no longer fully spoke. A record of time measured on a scale larger than cities, larger than dynasties. Seen this way, the king list aligns with everything else Sumer leaves behind. Writing that appears complete from the beginning, laws that arrive fully formed, cities that emerge already planned. Everywhere, Sumer behaves like a culture continuing something rather than starting it. The list does not explain where the earlier knowledge came from. It does not name the people who tracked the skies before the flood. It does not describe how long that world lasted. It only insists that it existed, and that something terrible ended it. What remains is a document that refuses to fit neatly into myth or history. It sits between them, rigid in form, strange in content, preserved with care across millennia. If it is wrong, it is wrong in a very disciplined way, and if it is right, then it is not telling us who ruled first, but when the world itself changed. And that possibility reshapes the entire story that follows. They were guarding something whose original meaning had already begun to fade. And that alone suggests the king list may not belong solely to Sumer, but to something older that Sumer inherited. Civilizations often reuse what came before them. A medieval cathedral can rise proudly in the 13th century while resting on stones shaped by Roman hands centuries earlier. The building is new, but its foundations remember an older world. The Sumerian king list may function the same way. Its clay is Sumerian. Its script is Sumerian. But the logic beneath it, the strange arithmetic of time, the division of history into cosmic eras, may belong to a civilization erased before Sumer ever named itself. The king list describes a time before the flood when rulers governed for spans of time that defy biological reality. Not centuries, but tens of thousands of years. Modern readers are quick to dismiss this as fantasy, yet ancient cultures were not careless with numbers. In Sumer, numbers carried legal, religious, and cosmic weight. A single miswritten figure could invalidate a contract or offend a god. So, when impossible reign lengths appear again and again, across copies separated by centuries and geography, the numbers demand explanation rather than dismissal. Which brings us to the flood itself. Did such an event truly occur, or is it merely symbolic language for social collapse or dynastic change? In the early 20th century, archaeology provided an answer that few expected. In the winter of 1929, British archaeologist Leonard Woolley was excavating the ancient city of Ur, working beneath what was already one of the most spectacular discoveries of the ancient world, the Royal Cemetery. His goal was straightforward. Beneath the lavish graves of kings and queens, he hoped to find the earliest levels of the city. Simple huts, crude tools, the first traces of urban life. For weeks, his team uncovered exactly that. Pottery shards, ash from hearths, broken implements. The slow, familiar rhythm of early settlement archaeology. Then, suddenly, everything stopped. Below the occupation layer was nothing but clean clay. No pottery, no charcoal, no tools. Just sterile, uniform mud. Woolley initially believed he had reached natural soil, the undisturbed ground beneath the city. Many excavations end that way, but something about the layer troubled him. It was too thick, too consistent. Acting on instinct more than expectation, he ordered the trench to continue deeper. 2.5 meters below the clay, human life returned. Pottery reappeared. Stone tools. Charcoal. Evidence of habitation unmistakably older than the city above. Woolley realized he was looking at two cities separated by a catastrophe. Between them lay a massive flood deposit, nearly 8 feet of water-laid silt, not the gradual accumulation of river overflow over centuries, but the signature of a single, overwhelming event. Water that arrived suddenly, violently, and with enough force to erase all traces of life before it. Woolley described the profile as a historical sandwich. Civilization, disaster, civilization again. When he published his findings, newspapers around the world seized on the headline, "Evidence of Noah's Flood Discovered." Woolley himself was cautious. He knew the flood was not global. The layer did not extend to the mountains, but within the low-lying plains of southern Mesopotamia, the effect would have been total. Every settlement along the rivers would have vanished beneath the water. For the people living there, it would have felt like the end of the world. The dating of the flood layer placed it around 2900 BCE. That date was not approximate. It aligned almost perfectly with the moment in the Sumerian king list when history breaks. In 2, the flood swept over. After the flood swept over, kingship was lowered from heaven again. Was not alone. At Shuruppak, the city named in Sumerian flood myths as the home of the survivor king, archaeologists uncovered the same sterile clay layer, nearly 2 meters thick. At Kish, another major center, the pattern repeated. Occupation, flood, rebuilding. At Eridu, traditionally remembered as the first city where kingship descended from heaven, evidence points to abandonment followed by reconstruction after a major inundation. Not every Sumerian site bears this scar. Cities built on higher ground escaped the waters. Others were founded afterward and carry no memory of the disaster. But across the floodplain, where the Tigris and Euphrates converge, the geological story is consistent. Around 2900 BCE, something catastrophic occurred. The archaeological evidence confirms that the flood described in Sumerian texts was not metaphor alone. It was a real event, powerful enough to divide memory into before and after. And the story does not end in Sumer. Long after the floodwaters receded from Mesopotamia, the memory of that catastrophe echoed outward across cultures and centuries. In the Hebrew book of Genesis, a righteous man is warned of an impending deluge and instructed to build a vessel. He preserves his family, animals, and seeds of life. When the waters withdraw, the world begins again through his descendants. But Genesis was not the first telling. More than 1,000 years earlier, the Akkadian epic of Atrahasis recorded a strikingly similar account. Humanity grows too numerous. The gods decide to destroy it with a flood. Enki, god of wisdom, secretly warns Atrahasis to build a boat. He survives with his family and animals. After the flood, the gods regret their decision and restructure the world to prevent such devastation from happening again. Fragments of an even older version, written in Sumerian, name the survivor as Ziusudra, king of Shuruppak, the same city where archaeologists found the flood layer. Geography and geology converge. Myth and mud tell the same story. Further north, Ugaritic texts describe a cosmic struggle between order and chaos, embodied by a sea deity threatening to overwhelm the world. In India, ancient scriptures tell of Manu, warned by a divine fish, who builds a boat and saves life from a world-ending deluge. In Mesoamerica, Aztec traditions speak of previous worlds destroyed by flood, with only a pair of survivors repopulating the current age. These cultures had no direct contact. They developed independently, separated by oceans and millennia. Yet their flood narratives share a specific structure: warning, survival, preservation of life, and rebirth after total devastation. Some scholars argue this reflects universal human psychology. Floods are common disasters, so flood myths arise naturally. But this explanation struggles to account for the consistency of detail. These are not vague stories of heavy rain. They describe singular, world-dividing events that reset time itself. Another explanation proposes regional catastrophes remembered locally and later exchanged through trade and storytelling. That may explain some parallels, but a growing body of evidence points to something larger. At the end of the last ice age, between roughly 12,000 and 10,000 BCE, global sea levels rose more than 100 meters as massive ice sheets melted. Coastlines disappeared, river valleys flooded, entire ecosystems transformed. If early human settlements existed along now submerged shores, and increasing underwater archaeology suggests they did, then vast populations would have been displaced or destroyed. If survivors carried stories of the world before the waters, those memories could persist through oral tradition for thousands of years. By the time writing emerged, those ancient memories would already feel mythic, yet still carry the emotional weight of lived experience. Sumer, with its early writing system, may have been the first culture capable of recording that inherited memory in permanent form. Which brings us back to knowledge. If a flood destroyed an earlier civilization, how did sophisticated systems of mathematics, astronomy, and measurement appear so suddenly in Sumer? Why do the earliest tablets already display advanced concepts with no visible developmental phase? The Sumerian numerical system is based on 60, not 10, not 12. 60. It governs time, angles, astronomy, trade, and architecture. 60 minutes in an hour, 360 degrees in a circle. Astronomical coordinates still divided by multiples of 6. 60 is mathematically exceptional. It is divisible by more numbers than any smaller integer, making it ideal for fractions, trade, and geometry. This is not an accidental choice. It is a deliberate one. Yet the earliest Sumerian tablets show no experimentation, no discarded alternatives, no gradual evolution. The system appears fully formed. In scribal school texts used to train children, the language is revealing. The art of writing, the texts say, comes from distant days. Not invented here, not recently discovered, simply inherited. Students learned multiplication tables reaching into the thousands. They solved problems involving compound interest. One small clay tablet quietly undermines nearly everything we assume about the limits of ancient knowledge. Catalogued today as YBC7289 and stored at Yale, it is unremarkable at first glance. Roughly palm-sized, browned by age, covered in neat wedges pressed into clay by a student's stylus. But etched onto its surface is a geometric diagram. A square, its diagonals drawn cleanly from corner to corner. Next to one diagonal appears a number written in sexagesimal notation. When converted into modern decimals, it reads 1.414213. That number is the square root of 2. Not an approximation rounded to 2 digits, not a rough guess, but an accurate value carried to 6 decimal places. To arrive at it requires more than arithmetic. It requires an understanding that some quantities cannot be expressed as simple ratios. It requires grappling with irrational numbers, a concept that, according to conventional timelines, should not exist for another 2 millennia. Yet here it is, written not as a philosophical curiosity, but as a classroom exercise. The tablet is not framed as a discovery, it is a copy, a student reproducing a known result from an older source, which means the insight itself predates the tablet. perhaps by generations. This pattern repeats across Sumerian knowledge systems. Their medical texts, for example, do not resemble the tentative experiments of an early healing tradition. They read like manuals compiled after long familiarity. A tablet from Nippur, dated to roughly 2100 BCE, lists remedies with specific ingredients, preparation methods, and intended effects. Thyme appears in treatments for respiratory conditions. Willow bark is prescribed for pain and inflammation, containing salicylic acid, the same compound modern medicine refined into aspirin. Fermented mixtures are used to aid digestion. Mineral compounds are included with cautionary instructions. This is not guesswork. These remedies are effective. Modern pharmacology has verified that many of the substances used contain biologically active compounds aligned with their prescribed purposes. Such precision does not arise from a handful of lucky accidents. It emerges from long observation, generations of trial, error, refinement, and record keeping. Yet when these medical tablets first appear in the archaeological record, they are already mature. There is no visible developmental phase, no surviving texts showing crude attempts or abandoned theories. The knowledge arrives assembled. Metallurgy tells the same story. By the early 3rd millennium BCE, Sumerian craftsmen were producing bronze of consistent quality. Bronze is not a forgiving material. It requires precise temperature control and careful balance between copper and tin. Too much tin and the alloy becomes brittle. Too little and it fails to harden properly. The optimal ratio hovers around 12% tin. Sumerian bronze artifacts repeatedly hit that ratio. Weapons hold their edges, tools resist deformation, decorative items display uniform casting techniques. There is no archaeological trail of failed alloys or experimental phases. The earliest examples already show mastery. Either the Sumerians learned metallurgy from an external source, or their learning curve occurred so early that it vanished beneath later layers, erased by time or by catastrophe. Their legal systems show comparable sophistication. Long before Hammurabi engraved his laws into stone, Sumerian cities maintained legal codes that distinguished between intent and accident, regulated contracts and debt, defined inheritance rights, and addressed property disputes with nuance. These are not simplistic rules. They reflect a deep understanding of human behavior and social conflict. Legal complexity typically evolves slowly. It grows through precedent, through cases that expose gaps in earlier rules. But Sumerian law appears comprehensive almost immediately, as though its architects already understood the full range of disputes a society might face. And then there is the sky. The astronomical tablets attributed to the reign of Amisaduqa, copied around 1650 BCE, record the movements of Venus over a full 21-year cycle. These are not poetic observations. They are logs, dates, positions, appearances and disappearances marked to the day. When modern astronomers reconstruct Venus's cycle backward, the data aligns with remarkable accuracy. Such precision cannot be achieved casually. Venus does not follow a simple path. Its synodic cycle spans 584 days, meaning identical configurations repeat only after long intervals. Recognizing the pattern requires sustained observation across decades, with records carefully preserved and compared. And the Amisaduqa tablets are copies, which means the original observations began earlier, likely centuries earlier, embedded within an institutional tradition of skywatching that endured long enough to recognize long-term cycles. The same tradition tracked eclipses, eventually identifying the Saros cycle, the roughly 18-year period after which eclipse patterns repeat. Detecting that pattern requires not just observation, but memory across generations. The architecture reflects the same precision. Ziggurats were not merely symbolic mountains for the gods, they were instruments. The Great Ziggurat at Ur, rebuilt around 2100 BCE atop older foundations, is aligned to the cardinal directions with an error of less than a single degree. Its stairways correspond to solar events, including solstice sunrises. Achieving this alignment demands an understanding of the sun's annual motion, careful horizon observation, and tools capable of measuring angles reliably. The Sumerians also compiled star catalogues, grouping constellations into recognizable patterns that marked seasons and directions. Many of the constellations they named, the bull, the lion, the scorpion, persist in modified form today. These were not decorative myths, they were navigational and agricultural tools, celestial coordinates encoded in story. Taken together, the evidence presents a problem: mathematics that anticipates later theory, medicine grounded in effective compounds, metallurgy without trial phases, law without visible evolution, astronomy requiring centuries of observation, architecture aligned with celestial mechanics. All of it appears in Sumer without the gradual build-up we expect from human innovation. The archaeological scaffolding is missing, which brings us back to a recurring phrase in Sumerian texts. Knowledge was given. We have long interpreted this as mythology, ancient people crediting gods for achievements they could not explain. But that interpretation assumes ignorance where there may have been memory. What if given does not mean divine revelation, but inheritance? Passed down from teachers whose origins were already lost to time. The flood layer beneath Ur is more than sediment. It is a break in continuity. Beneath it lies evidence of an earlier culture with distinct pottery styles and tool traditions. Above it rises Sumer, already sophisticated. If a catastrophe erased the physical traces of an earlier civilization, only fragments of its intellectual legacy might remain, carried by survivors, preserved orally, embedded in practice long before writing fixed it in clay. If so, Sumerian civilization was not a beginning, it was a recovery.